So, we have a question about magnetism. And the question goes like this. You're driving along in your car, going your car's maximum velocity. Now, during that time, friction with the air has caused you to build up a substantial 50 coulomb charge. Now, this might seem kind of crazy, but as strange as it sounds, this is actually a real problem, especially for helicopters. Those blades spinning around cause the helicopter to build enormous charges. And that's one of the problems that often helicopters have when they're trying to rescue somebody. They got a metal cable, they got a huge static charge, the cable comes down to the salt ladder, and if they're not careful, they can literally shock and disable the person they're trying to rescue. So, well, they drop the cord and then they move closer to the person who's in trouble. But this can happen. Your car can pick up one heck of a static charge. Now, here's a question. The Earth has a magnetic field, right? So, if the Earth's got a magnetic field, what's going to be the effect of the magnetic field on the charge of your moving car? So, we have our formula. Now the formula is F, which is a vector, is equal to QV, also a vector, cross B. Let's figure it out. So the force, now in this case the charge is 50 coulombs. Now, note that this is not a cross product. This is a dot product. Times my car's maximum velocity is 42 meters per second. And it's got a direction. My car is driving east, okay? That does matter in cross products because everything's a vector. Now, in the creation of the problem, I've made a mistake. I've said that the Earth's magnetic field is 40 microteslas south. That's not true. In fact, the Earth's magnetic field in the Los Angeles area is slightly stronger, about 48 microteslas, and it goes north. But since I've already got the problems up, I'm going to go ahead with this, and I'll have to create another version of this later. Okay, so anyway, here we go. So I've got 40 microteslas is 4 times 10 to the negative 5 teslas. And since I told everybody this in the problem, during class today that it was south, we're going to go south. It's not really south, it's north, and it's not exactly perfectly north because magnetic north is not actually at the North Pole. We're just going to do this, okay? We're just going to use the numbers the bad numbers I gave you. I'm sorry, I'm so sorry, I'm so sorry. Anyway, moving ahead. Okay, so let's just start plugging through here. F, which is also a vector by the way, is equal to multiply 50 times 42, and I got 2,184. And of course the direction is still east. And well, 4 times 10, that's going to wait. And we'll do something with that later. Still south. I know it's north. I know this isn't true. We're just going with it, okay? Multiply 4 times. Now, by the way, I notice a lot of people have trouble with scientific notation. There's a couple different approaches we can use here. So let's just multiply this. So I get 8,000. 8,000, what did I get? 736 times 10 to the negative 5. Now, we got two different approaches. I'm going to do them both. You can either keep this in scientific notation or you can write this regular, ordinary wise. Now, if it's scientific notation, this will be 8.7, roughly 8.74 times 10. Now, what we're going to need to do is we're going to move the decimal point 1, 2, 3 times to get it there, which means that we're going to be adding 3 to this. Negative 5 plus 3 is negative 2. And our units would be newtons. Or I can do it this way. I've got 8. I can move the decimal point 5 places. 1, 2, 3, 4, 5. So in my case, 0.0874. I'm just going to round it to 3 places. I need to redo this problem. And again, this is newtons. Now, by the way, these are the same. There is no difference. They're exactly the same. Just two different ways of writing the same thing. One thing I will say though, this is a vector. We're not done yet. So, let us start out with the right-hand rule. So, it is east crossed south. So, now in our case, east is towards the board. That's just the way the board is. And south is that way. So, east cross south is down. So, we're going to put down our direction as, well, down. Right? Down. Now you could write down, I like to just point an arrow downward, but that's your direction. Now, by the way, I goofed. Actually, the magnetic field pushes roughly north, so our number should actually be the opposite. It should actually be up. It would be making your car a tiny bit lighter. Now, by the way, the numbers, think about the numbers. They're very small. Have you ever felt, magnetic field of Earth pulling on you? Even in a jet plane where you're going 500 miles an hour, have you ever felt it? Yeah, it's small. It's a very, very small force. But it's real. Anyway, there you are. I will see you in a few minutes. Bye-bye. Oh, by the way, quick little note here. If your car is faster than mine, well, QV is going to be greater. Your number will be bigger. It's not going to change the direction, but your car will have a slightly larger, tiny force on you. Okay?